Hi everyone, welcome to my channel. So today I'm going to share with you my insights, my processes and insights for my data mining and data wrangling subject for my MDS 206. So I'm just going to briefly share with you my processes and some insights on my results of my paper. So my paper is entitled 3D or Data Driven Dating. So I hope you learn something and enjoy. I actually went and created an account for Lovo and used a VPN just to access their website. I want to check if their features actually matches the date variables in the dataset that I gathered from Kaggle. So here it goes. So here it is. So my paper is called 3D or Data Driven Dating. So Lovo, to give you an overview of the data set that I've gathered from Kaggle, it's about Lovo, an app from Germany. It's a popular dating site, and now they come up with a mobile app, and their target users are European countries. So aside from descriptive analysis, similarity-based learning, error-based learning, support vector machine algorithms are also used to derive and compare machine learning approaches. So first, data processing. The first step I've done is data processing, then data cleaning. So the aim here is to impute values that are null or that are missing. Then we have the exploratory data analysis, and then I split the data into training and testing set into 80 to 20 ratio. So that's when I do similarity based learning and error based learning. So I've also checked if the data needs to be scaled. Okay. So results show that Switzerland, Denmark, France, and Italy are the top four European countries where the female users are coming from. So this dataset only have around 600 instances, and they are all data from female users only. So I don't have the profiles and profile details of male users of Lovo app. So female users are aged 22 on average. So you can see here this is the density plot. So they are at least 18 years old. And the cluster is around 20 to 24. So a lot of 22 years old women from either Denmark, Switzerland, Italy, and France are using this app. So dating app interest is on chatting. So before anything else, um, when you get to the app itself, it will ask you what are your what are your purpose for making a profile. So you can choose all of the three options, or you can choose either one, or it's up to you. And the three choices given were for chatting, friendship, and dating. So results show that the dating app interest on chatting, a lot of, all of the respondents, majority of the respondents answered true, that their app interest in the dating app is only on chatting. Then, dating app interest is on making friends. The majority also said that it's true. However, when asked if they are using the app for dating, um, a lot of the users said it's false. So only chatting and dating are their main interests. So the next one would be the mean profile visits per interest. So I've got the mean and the mean difference of for those who answered true or false. So it can be shown here that um, the chat, the interest for chat has the highest mean, followed by dating and then friendship. So the one here with the highest mean difference implies that the true or false responses significantly differ from these choice, which is chatting. So it's followed by dating, and then it comes with friendship. So mean language profile visits per language spoken. So these are the results. So English comes first. A lot of the users speaks English, followed by Spanish, then Danish, Italian, Danish, then French. So the highest mean difference between the languages are in English and Spanish. So this is the data for the mean of profile visits per language spoken. So you can say that a lot of visits are generated from English and Spanish speakers. Here, this shows the um, bar plot of the number of languages spoken and their number of fans. It can be shown here that the higher the number of languages spoken does not mean an increased number of fans. So non-bilingual female, it can be shown here, non-bilingual female profiles get the most number of fans. So the zero here doesn't really mean anything because when you use the Lovo app, it lets you skip. If you don't write the languages that you speak, you can just skip it. So this is the number. That's why it's indicated here as 0. So the next one, the scatter plots here, visually by visual inspection, it shows that there's no significant relationship between the variables here, the count details and the count of kisses. So when you use the app, you can actually give a virtual kiss to the profile. So the profile does not indicate a significant increase or decrease in the number of profile kisses. And then the number of pictures does not indicate a significant increase or decrease in the number of profile visits. So it doesn't matter how many pictures you put on your profile, it doesn't really affect your number of profile visits. Then the number of pictures does not indicate a significant increase or decrease in the number of fans. Okay? So that's it for the descriptive analysis. We then go to similarity-based learning by KNN classification. So this is the K nearest neighbor classification method, and our aim here is to our aim is here for KNN is to use these feature variables here, these bulleted points, to make a classification model to predict if the flirt interest here is to date. So here, the flirt interest is binary response, true or false. So in determining the K nearest neighbors, the error rates and the K values are plotted. So the lowest error rate in the plot is assigned to be the value of K. So looking at the error rate here, the lowest error rate here is 27. So I set the by parameter tuning, I've set the K equals to 27. So then we have the confusion matrix here. So this doesn't really show a good result because it implies that if we use this classification model, we are more likely to have a type 1 error because we have a true positive here, but then we have a false positive here. So it would mean that we will have profiles that their primary goal for the dating app is not to date, but we classify those profiles as a true. So that this signifies the 231 number here implies that we're committing a type 1 error. So this is the accuracy score for the KNN classification. The metrics here is by Euclidean distance, and the training and testing scores are here. So they're around 0.64 and they're around 0.60. Okay. So here we have the error-based learning by regression. We have the regression here, and we have logistic, ridge, and lasso. So for logistic regression, the by parameter tuning, we have the best C here is 1 for both validation and testing, and the accuracy score is still around 0.6 for both validation and testing. For ridge regression, so mind you, the logistic regression here has an unpenalized loss function, so there's no regularization in the loss function. But in ridge regression here, we have this score. So the the best parameter C here is equal to 4. So the accuracy score is still around 0.60. So I've actually tried different values for C, and it yielded results. If I go lower, it yielded results 0.5 accuracy score. Even though if I go higher, it still yields around 0.50 accuracy scores. So the best C value here is 4. So this is the visual plot of the validation and accuracy score. We can see that the accuracy scores falls closely to each other until at the end the test accuracy score drops here. It becomes lower as the C increases. For lasso regression, this is L1 regular L1 penalize its penalization is L1 regularization for the loss function. The best parameter here is 0.03 for both validation and testing sets. And the accuracy score is still around 0.60. So again, looking at the lasso regression plot for accuracy scores, we can observe that the validation and accuracy score lies really close to each other, and it's very consistent. So it is better than what we have for ridge regression. We have the consistency of the accuracy scores here. So there's no inconsistencies here. So we have error-based learning by support vector machines, or SVM. Here we have the SVM algorithms I used are linear, RBF, and polynomial. So the best parameter for the linear is 0.1. The C set for by the CV here, the cross validation is 5, so that we have 5 folds, and the best parameter for linear SVM is 0.1, and the accuracy score is still 0.6, around 0.6. For RBF, the RBF kernel is used here, and 0.1 is the best parameter. The parameter here is gamma, not C. Then for accuracy score, it's still 0.6. And for the polynomial, the best parameter is in C equals 10. So the accuracy score for polynomial testing is 0.62. So just to summarize everything, I have these following points. So KNN classification may produce type 1 errors, and in comparing the training and testing accuracy scores, the results may suggest an overfitting. So this is not, the overfitting does not, isn't particularly true, but because the testing and training scores does not significantly differ from each other. The second point here is that lasso regression performed the best in the error-based learning, as the difference between the training and testing accuracy scores does not severely deviate from each other. So if you recall the slide for lasso regression, their accuracy scores remains constant. So in terms of SVM, RBM performs the best as it yields the highest accuracy score when compared to linear and polynomial SVM. So overall, the model we'd like to use to present to make predictions for classification is the lasso regression. So the results of this paper isn't really nice because the accuracy score is 0.60. So what would be the recommendation here is that we gather more data and maybe do some feature engineering just to see and try which target variables are performs the best when predicting the our target variable, which is the flirt interest date. So that's all I can say. So I hope that you enjoyed this video, and if you have any questions, just leave it on the comment section, and I'd be happy to answer it. So thank you for watching. Have a great night ahead. Bye.